Use the graph to answer the following questions. Let's go ahead and take a look. So we have a learner in a car moving at a constant velocity of 10 meters per second along a straight horizontal road. The learner records the frequency of sound emitted by a distant stationary source. The learner then repeats the recording of the frequency of the sound when the car travels at a new constant speed of 20 meters per second. The graph below, not drawn to scale, is obtained from the results. So let's go ahead and analyze this graph. On the x-axis, we have the speed of the car in meters per second. And then on the y-axis, we have the recorded frequency or the frequency experience. That will be FL, the frequency observed by the listener. So let's analyze this graph. When the speed of the car is 0 meters per second, the frequency recorded is 700 hertz. We're going to come back to that. And then when the speed of the car is 10 meters per second, the recorded frequency is 679.1 hertz. And then when the speed of the car is 20 meters per second, the recorded frequency is 658.2. Right, so let's make sense of this frequency when the speed of the car is 0 meters per second. When the speed of the car is 0 meters per second and our source is stationary, there is no Doppler effect. The frequency or the pitch observed doesn't change, right? So this 700 hertz that we have here, it's actually the value of Fs, the emitted frequency, because it's the frequency we have when the speed of the car is 0 meters per second. So this is actually the key to this question. As soon as you understand that, then all the other problems that come are quite easy to solve. Right. So this video is one of 4. In this little experiment that we have, you had to realize that you're given Fs. And then in the other questions that we're going to be solving soon, there's going to be different tricks. So that's actually what I want us to go through. How do we interpret a question when we are given a graph or when we are given a table with data on it? That is the skill I want to teach you, because most of the time with Doppler effect, you're going to come across a situation that you've never seen before, and you have to be able to analyze that situation. Let's take a look at the first question. Write down the frequency of the sound emitted by the stationary source. Give a reason for the answer. Well, we have talked about that. We know that the frequency emitted by the source is 700 hertz. And why do we say that the frequency emitted by the source is 700 hertz? Because that is the frequency recorded when the speed of the car, velocity of the listener, is equals to 0 meters per second. And the velocity of the source is also equals to 0 meters per second. When this is the case, when the listener is stationary and the source is stationary, there is no Doppler effect taking place. There's not going to be a change in the frequency observed. So that is why we are saying that the frequency emitted by the stationary source is 700 hertz. As soon as you realize that, everything else becomes doable. The second question, in which direction is the car moving relative to the source? Choose from towards or away. Give a reason for the answer. So right, again, we need to answer this question basing it on the graph that we have. So take a look at this. I'm not sure if you realize, but when the speed of the car is 10 meters per second, the observed frequency is 679 hertz. And then when the speed of the car increases to 20 meters per second, the observed frequency is 658. So as the speed of the car increases, the observed frequency is decreasing. So clearly the car is moving away because of that. If it was increasing, the car would be moving towards. So what are we saying? In which direction is the car moving relative to the source? It is moving away. Why do we say that? As the velocity of the listener increases, FL decreases. So the listener has to be moving away from the source if that is the case. Right, as the velocity of the listener increases, FL, the observed frequency, decreases. That is question 2. Let's go ahead and take a look at the third question. Calculate the speed of sound in air. Right, calculate the speed of sound in air. So we know that we are looking for V. We know fully well that Fs is 700 Hz. That is the emitted frequency by the source as it is. And then what else do we have? Let's go ahead and take a look. So we have two data points we can use. Say that you can use these first data point or you can use the second one. Because if you use this point, you have FL and its corresponding VL. And then if you use the second point, you're going to have FL and its corresponding VL. So whatever point you decide to use between these two, you're going to get to the same answer, right? So let's use these very first point. Let's use this point here. So if we use that point, then we would have FL being equals to 679.1 Hertz. That is the observed frequency. And speed of the car, so that is VL, because it is the listener that is moving in a car, right? So VL will be 10 meters per second. And then Vs is equals to 0. We know that our source is stationary. So with this data, we can then use FL is equals to V plus or minus VL divided by V plus or minus Vs multiplied by Fs. We know fully well that our listener is moving away. So if it's our listener is moving away, we're going to have V minus VL divided by V. Our source is stationary, so plus or minus 0. It's not going to really change anything. Multiplied by Fs. Right, here on the numerator we have minus because our listener is moving away. We can go ahead and substitute now. FL, the frequency observed, we have 679.1 being equals to speed of sound in air, so that is V minus the velocity of the listener, 10 meters per second. Everything divided by V, multiplied by the frequency emitted. So there we go. We have solved the physics equation, right? Now we're just solving for V. It now becomes a mathematical problem. Let's divide both sides by 700. If you divide on the right hand side by 700, 700 and 700 will cancel out. So we're gonna have 679.1 divided by 700 being equals to V minus 10 divided by V. Let's go ahead and cross multiply. So 679.1 V is equals to, we are multiplying 700 with that, right? So 700 V minus 7,000, right? So let's take this to the left hand side. So I just need to put that in my calculator. 679.1 minus 700, that is minus 20.9. So minus 20.9 V is equals to minus 700. So V is equals to minus 700 divided by answer will give me, hey, I was getting surprised. This is minus 7,000, minus 7,000. Here it is. We bring it here and we take this to the left hand side. Right, so it is minus 7,000. I was surprised. My answer was not making any sense. So V is equals to 334.93 meters per second. And there we go. We have our speed of sound in air.